Hello everyone, in this video I will present my exploratory data analysis or EDA on a dataset that examines the impact of generative AI usage on students' academic performance, study habits, skill retention, and burnout levels. If you have watched my previous video, you must have seen that we had this dataset AI student impact dataset, which was in a comma separated values file, which we cleaned and pre-processed using this particular Python file, and hence we got this cleaned AI student impact dataset where we had these normalized values replacing the missing values. And so we come here to our AI student EDA Python file which is going to be used for our EDA. The purpose of this analysis is to understand the data set, identify important patterns and relationships, and gain insights that can be useful for further research or machine learning applications. The very first thing we did here is import the important libraries, which are pandas, matplotlib, seaborn, os, and then we load our cleaned AI student impact dataset. And then we make a folder for plots where we will have all our important plots for various purposes. And then upon running the file, we get this, which is the dataset shape 50,000, 16, which indicates that we had 50,000 rows and 16 columns, right? We have our column names printed here, and we had all these 16 columns starting from student ID and ending at burnout risk level. And we also have the data types mentioned here listed for all the various columns. So these are mostly like float and string, and there's one boolean as well. So yeah, and we have no missing values for any of the columns whatsoever. And we have the summary statistics here, which is the count, mean, standard, minimum, 25 percentile, 50 percentile, 75 percentile, max, all these values for all our different columns. And yeah, so when we run this program, we also get various plots, right? And we have all these plots in white grid. So the first plot we get here is our distribution of weekly Gen AI hours. And here we will have our the Gen AI hours distribution plot. So as you can see, this is a right skewed graph because the tail is longer on the right side. Okay, so we can see here that the hours per week is mostly from 0.0 to here like 0.2, and it's gradually decreasing and increasing just at this one place, which is not that much. So most students are not that much dependent on AI, Gen AI. So this is what we can conclude. This is mostly the range where we have the highest number of student count. So like most students are not using Gen AI that much. All right, now again coming back to our program, we have printed the correlation heat map as correlation heat map. Yeah, so a very important thing in the correlation heat map is that whenever one value, suppose a value in this like row, if one parameter is increasing, then the other parameter must be decreasing, and the value that we get will be negative. But if the value is positive, for instance here where we can see 0.67, so 0.67, it's a positive value, which indicates that if weekly Gen AI hours are high, perceived AI dependency is also high. But we have this negative value here, minus 0.16, meaning if traditional study hours are suppose less, then it indicates that weekly Gen AI hours were high. So these are like inversely related. All right. Now we come back to our Python file again, and we have printed the burnout risk level. So the burnout risk distribution can be seen here. So it's kind of a bar graph, right? So most students are at a medium burnout risk level, and the number of students are mostly concentrated in this particular burnout risk, and the next majority is in the lower burnout risk, and then it's followed by people who fall into this high burnout risk category. So we do see some differences, but we see that majority of the students are actually in the medium burnout risk level, right? Coming back to our Python program, we see major category distribution. So what is this major category distribution? All right. So there are these 5 major categories: humanities, medical, business, STEM, arts, etc. And these are the count of students. So we see mostly the highest number of students actually belong to STEM, who are using Gen AI, which is then followed by business, then humanities, and then medical, and then arts. So the art students are the least dependent on AI, which we can see from this graph. Then again, coming back to the Python file, we have this GPA before versus after semester. So this has been saved as GPA comparison. So we see a large cluster here. So most of the students who scored well in pre-semester GPA, they also scored well in the post-semester GPA. Each dot represents a student, and the few students who scored less in pre-semester, they also scored less in post-semester, right? So that's the basic implication of this scatter plot graph. So we can see there's a consistency. So if somebody is starting well, they also end well in their academic year. Then next we come to AI usage versus post GPA graph. So the AI usage versus post GPA graph has been saved as AI hours. Alright. So weekly Gen AI hours. So the majority of the students lie between this 0.0 to about 0.3, 0.4, this category. So the weekly Gen AI hours lie in this category, and their post-semester GPA is also kind of consistent. If 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 the student use 0.0 to 0.4 weekly Gen AI hours, so their post semester GPA was this much. So most students are using it this much, not heavily dependent but dependent, and this is their post semester GPA. So they are scoring good irrespective of their weekly Gen AI hours. There are students who use it a lot, and they are ranging from like 0.3 to here, but the number of students here is comparatively less. Coming back to our Python file, we have our next graph, which is study hours distribution. In this graph we see a box plot. Now what is a box plot? A box plot is basically a plot where we have this box which lies from the 25 percentile or the one third, I'm so sorry, one fourth quartile, and we have this third quartile, sorry, first quartile and third quartile. This line indicates the median, and we have two whiskers here. This is the shorter whisker, this is the longer whisker, and this is the minimum value, this is the maximum value. And we do have these, as you can see, we have some outliers here represented by these dots. The graph is for traditional study hours. So most students lie between somewhere around 0.2 to 0.4, and the median is at around 0.3, but a little bit lesser than that. So there are very few students who are highly engaged in studies, like they have a high amount of daily study hours, and these are the outliers, and they are the exception. But the majority, the 50%, they lie in this category, which is 0.2 to 0.4. Then again, coming back to our Python file, we have the AI dependency by burnout risk. Okay, this is another box plot graph where we can see that we have perceived AI dependency here and the burnout risk level here, and we can see that the high burnout risk level, where the perceived AI dependency is comparatively high, of course, and the median here is about 0.45. So the higher percentage of students are actually at a high burnout risk level, and they have high AI dependency as well. And for the low and medium, the values are similar, but we can see that we have outliers for the low and medium burnout risk level. So we have a few students here who have like a very high AI dependency, yet they have low burnout risk level. And then here also we have some people who have very high AI dependency, and yet they fall into the category of medium burnout risk level. So this is what is being indicated by this graph. And after this, we again come back to our So next we have skill retention distribution, which has been saved like this. Okay, now this is a left skewed graph, which is because the tail is longer on the left side, and it is count versus skill retention score. So most of the students have a good skill retention score, so they are good students, 0.6 to about 0.8, 0.85, and majority are at the 0.7 level. So most students have good skill retention score, so they can retain skills pretty nicely. Again, coming back to our file, in Python file, so the last step is primary use case distribution. So what are they basically using Gen AI for? It has been used as use case distribution. So we have count versus the primary use case. Here we can see that majority students are using it for troubleshooting. Somehow it's not visible here, but it's for troubleshooting, followed by like drafting, or just copywriting. All of this is for students, like the second group. After that, the next priority for students is ideation. They need ideation for various projects, etc., and followed by reading. And the last priority is answer generation. Like, it is also very widely used for answer generation, a criteria for which people use this Gen AI. But the first thing for which people use it, and the topmost thing, is troubleshooting. And with this we come to the end of our file, and one thing which I did was plot tight layout so that I could get all the labelings uh, inside the plots. And that's it for this video. Thank you.